In this video, I am going to demonstrate a process of creating a base plan from available data obtained from public online sources. During this process, I will touch on the GIS module, point cloud, and surface modeling. To begin with, most countries, and certainly most states in the US, have available online GIS resources with a large variety of information. Each GIS resource will be slightly different in the user interface, but most ultimately output similar data files. National resources are similar. For this demonstration, I will be using a state-published data for parcel, conservation, and soils, and national LiDAR and FEMA information, all available to download from the internet. Because each state is different, I will not go into detail instructions, but ultimately the objective is to download a shapefile, .shp, containing your desired information that can then be processed in Carlson. I will go into a little more detail with regards to NOAA, where the LiDAR data is available. On this site, for the state of Massachusetts, I am able to search and select information and then export multiple shapefiles in the form of a downloadable zip file. I can then extract those shapefiles into my project directory and begin the process of creating my base plan. I now start a new drawing. So just quickly on the open drawing, the one thing that has to be done is a projection is set, state plane, 1983, Mass mainland, and it needs to be a grid system. I'm in the survey module, and there's a pull down, GIS, and I have to first hit the GIS settings and set up two basic files, a GIS feature file and an output database. The feature file contains the names of the features and attributes for each element that's in the shape file. For example, a tax parcel would be the feature. Attributes for it would be things like the owner's name, book and page, size of the lot, map ID number, and those kind of things. So I create a feature file. The feature file could be the same one for the entire state of Massachusetts, so I could have one for every time I use Oliver, so this does not have to be created for each individual project. The output database, however, needs to be created for each individual project, because that's going to be where the data itself, meaning the owner's name and book and page and such, is carried, and it talks to the GIS feature file. So this is project specific, this is not. So I'm going to select one, and what I do is I keep one in my Carlson project settings called Mass GIS, and I'm going to hit existing because it's not new, and then the output database again is going to be a new. Go ahead and use access. I then browse and name the file, and I'm just calling this project base plan, and that's all it is to set this up. I'm now ready to import those shapefiles. So I can hit import Esri shapefile and select what be in the right folder. I'm going to bring in the tax parcels first. So I double click into that folder, and there is my shapefile. And I hit open, and I have an option to import the geometry and the GIS data, or just simply the geometry only. I want the GIS data, so I'm going to just hit import polylines from shapefile. And it takes just a little bit depending on how big the area was, but it's importing the polylines as well as the data, and there we are. It brings it in a layer. That was an option to set that. That's GIS data. And I'm going to leave those names in there so it indicates that it was GIS and not surveyed property lines. I'm now going to go ahead and bring in another shapefile, following the same procedure. And I'm going to go up a layer, and I'm going to bring in the wetland lines. This time I don't care about any information on the wetland lines, I just want the geometry. So I can click on geometry only, and it goes much faster because it's not populating the database with any information. Bring in another one. Layer, flood zones. Now I do want the data for the flood zones, so I hit import polylines. So it's going to go a little slower, and there's the flood zone lines. Everything is white because I don't have pre-prepared layers. So it brings in with the default color. I'm going to bring in one more, up a level, and we'll bring in the soils maps. Again, I do want the data for that, so I'm going to import those. I'm now quickly going to go into my layer manager and apply some colors to these layers for clarity, make my drawing a little easier to work in. Now I'm going to go about labeling some of this information, and I'm going to start with the parcel data, and I'm just going to isolate that for ease. GIS, label GIS polyline, close polyline data. I'm just going to use a crossing window and select all the parcels that I want to include. Hit return. It reads into the database and finds the information for each of those polylines. And then I select the things that I want it to label on the left and move it to the right. So I want a book and page. I want the map parcel ID number and the owner's name. And if I want to sort these, I think I would like the parcel ID up first, and I'll put parcel ID first, followed by the owner, and then book and page. And look at my text height. I'm working on a 40 scale, so I want a text height of 4. I have the field name for clarity that will be added. These field names will show up in the label. It's important to note that you can save this configuration and reload it for future projects. So you just save this externally in a file, and then when you want to perform this function again, you can just load that file and save you the process of dragging and dropping from left to right. You now hit draw, and it labels your parcel information. Now I'm going to pick one of them, hit select similar, and properties, and I would like them not to be left justified. I would like it to be center justified. So that's how I want them to look. So you can do that and change layers, whatever you want. I'm now going to follow the rest of them. Let's see what we have for the flood zones. Label close polyline data. And I have the zone. And let's just say I'm going to bring in the panel and draw that. There's the panel number and the flood zone that we're in. Again, I'm going to select those. Center justified. The wetlands are just the polygons. Remember, I did not bring in the data for the wetlands, but I can label the soils map as well. Same process. Close polyline. And there's my description of the soils. I'm going to take one more step in GIS, and to do so I'm going to switch to the GIS module, full module, and in there is a command to place Google Earth image. And it creates a external file that you need to name, and I'm just going to call it Google. and you pick from the screen. I'm going to pick right off the screen, and to do so I just pick 2 corners and make a box, and the program shows the resolution available anywhere from low, medium, or high, a layer for it to go on. I'm going to set to a layer that I do have prescribed in here, image layer, place in the background, and I hit OK. And the program goes out and reads Google Earth and drops in the image file based upon the graphic location of the site. Now I'm going to go another step with this, and that is to create contours for the site. And there's more than one way to do that, but my preferred method is to go out and use available Massachusetts LiDAR, which is more recent than certainly quad maps and is reasonably close with regards to sites that haven't been modified in the last several years. To do this, I'm going to utilize Carlson's Point Cloud program. Before I do that, I need to export the LiDAR information for this area. So I go back out online, and I go to NOAA's LiDAR site, which is this address, coast.noaa.gov. And you can make your way into the data viewer, and I can search by address. Put in this address, 280 Rocky Hill Road, Plymouth. And what you see, you zoom into that area, but you need to zoom out. I'm just using my middle button to scroll out until I get far enough away that it will actually display the available data. And there we go. So depending on what's available, so what I'm going to do now is draw a search area. And this is my site that I'm looking at. This is Rocky Hill Road. You can see where we are here. So I'm going to make sure that I cover everything that we want in that site, and I'm going to just draw a box. It highlights the area if the information is available, and then I have choices about what I would like to export. What I would like is the 2013-14 post-Sandy LiDAR information. So I just come over here and I hit Add to Cart. I go to my cart. It shows what I've selected. Next, you notice the default geoid is now geoid 18. Check your projection, again, 1983, NAD 83, and the vertical datum of NAVD 88. The zone, Massachusetts mainland. Horizontal feet is US feet. And then our output product can be a raster image, a point file, or just contours. So instead of just downloading the contours, I'm going to download the point cloud, and the format is LAS. See that switch? The reason why I'm going to do the point cloud is then I can extract from that point cloud myself, manipulate it, and create a surface model out of just what I want instead of just merely getting the contour lines themselves. So I hit Next, and I have to put in an email address, and I hit Next. You get a chance to check, make sure you got your projections and your datum correct. Everything is correct, you just hit Submit, and then you wait for an email from noaa.gov. That email will notify you that it has finished processing, your order is complete, and it's ready to download. So at this point, we can close out and wait for that email. So I have received a confirmation email from NOAA that my project is in progress, and eventually I will get another email that confirms that the process is completed and with a link to download it. But I can also click on this link and go check the process and see if it's done manually. So I'm clicking on that, and it shows right here that the job finished successfully, so I can download it. And at the bottom of it gives me a website address of where to download a zip file containing that LiDAR information. So if I just copy and paste that information up here, it launches the website and download, and I just hit save. Again, the length of time that it takes to download it will depend on how big the file is, which is going to depend on how big the area is mostly. Also the density of the cloud itself. This is a wooded site, so it's not going to be that dense of a cloud. I now can open the folder. I get another zip file that I can extract into my project directory. What I get is an LAS file along with the metadata. Go back to my drawing, and I'm going to launch Point Cloud. First time I launch it, it brings up the project manager. I'm going to hit New to create a new cloud file, which is a .pc file. I'm going to stick with the same name, base plan. I'm going to create it now. This is the main project panel, and I will be using the project panel as well as the action tab. I start by a cloud, and I right click and import LAS file. I browse to my project directory and grab the LAS file, import it. I have an option to convert if I was in different units. I do not need to convert because I exported with the same units as what I want to use. So there's my LAS file brought in. I can right click on that, look at the properties, and see is 207,000 points. It's not a very dense cloud, but it does give you the minimum and maximum elevation range. If I'd like to look at this, I can right click and hit view, or just simply double click on it. It creates a scene. I'm just going with the default names and hit OK. And there's the cloud. This cloud is colored based upon elevation, blue being the lowest elevation. That's actually out at the sea level, but it's not seeing that as water. It is seeing that as a low elevation, and the green and the red is the highest elevation. The holes are from the adjacent houses that you see. So this cloud is classified, in what we're looking at here are ground points only. So we don't have to filter anything out manually. Now, one of the things I really like about Point Cloud is the fact that you can jump in and out of your CAD environment back to the cloud without closing out any programs. So to prepare for the topography, I'm going to jump back into CAD and create a boundary of the area I would like to topo. Now, to prepare for the limits of the topography that I want, I'm going to first freeze some of the layers that I have. As a matter of fact, I'm going to freeze everything except the parcel lines. And I don't want my topography to extend all the way out into these other parcels, so I'm going to take this polyline, I'm just going to offset it by 50 feet using a regular AutoCAD offset command, 50 feet. And I'm going to use that to trim out the cloud to limit the topography to stay within only that area. So now I'm going to go back into Point Cloud, just pull the Point Cloud Manager back up and the graphic view. And I'm going to go into Process Data, hit Polylines, and read from CAD and select that new polyline. Now you can see the polyline partially, And if you tip up, you can actually see it under the surface. That's because the polyline is at elevation 0, and which is below the site elevation. So I can come in and edit that polyline, and what I'm going to do is raise the elevation. I can do that by selecting all the vertexes of the polyline and hit the Transform Polyline button and add a sequence. And the only thing I'm going to change is the Z, and I'm going to change that to 200 foot. And close at that, and you can see behind the polyline is now visible at 200 foot, and I will hit OK. Pull that back up. I am now going to use that as a trim line by going back into the Action tab, and in my selection set, select Polyline, Cloud Points, and what's highlighted in red is included in that selection set. And I'm going to create a separate cloud out of that so as not to eliminate the rest of the cloud. And I'm going to create a cloud and give it a new name. I'm going to call it Site Only. I'm going to close out this box. First I'm going to hit None for selection, close out this box. Go back in, grab my Site Only, double click and create a new scene so I can see that. So there's my site. Go back into the Action tab, and I'm going to create points, Carlson points, throughout the site. And what I want to do is actually grid the entire site in a 25-foot grid. So I hit Create Point, scroll down, and you will see an option to survey by grid. So I click on that. I give it a point code. I'm going to use R for random. I'm going to give it a starting point number, and I'm going to designate it with an alpha code LD for LiDAR to indicate these are LiDAR points. Cell size is the grid size, which is 25 feet, and point within is a radius that corresponds to the elevation method. So this will find the lowest point every 25 feet within a 2-foot radius. And I hit OK. And it creates points throughout the site. I can now end that action. And if those points are too big, I can control that, selecting my coordinate points, and change the size from 12 to, say, 2. And now you can see much smaller points, but there's all the points set throughout the site. I'm going to save my project, and I go to my points. I'm now going to draw them into the CAD drawing using Field to Finish. It's asking me to create a coordinate file. I haven't done that yet, so I'm going to hit New, and I'm going to call it Base LiDAR. I'm going to select my code table and draw all the points. Thaw everything so you can see them. And there's all my points. I can now create a surface model out of this. Going into Surface File, Triangulate and Contour. Write a TIN file, and I'm going to call it LiDAR EX. Contour, elevation, 1 foot and 5 foot index contours. And I think I'm going to auto label this. 1 label per contour. Hit OK. And just window everything in. It's not going to grab these polylines that are outside of it because they're not elevated. There's my 1 foot contours throughout the site. One of the things you'll notice is that as I come to my road contours, since I went every 25 feet, I really don't have any break lines. And as this side goes back up the hill, I actually have contours probably within the roadway. And various contours that just don't look quite right. So depending on what your project is and what you really want to do with these base contours, we may now wish to edit those by adding break lines. To draw in those break lines, I'm first going to clean up the drawing and prepare this by freezing and thawing layers so I can see the Google image underneath and remove some of the rest of these lines. So what I'm going to do is create from Google Earth image the roadway and create a break line out of that from those graphic entities. So I'm going to start in CAD using my layer. I'm going to set to a break line layer and just simply draw a 2D polyline following the edge of pavement. I'm not trying to get exact. For the other side, I'm actually going to use an AutoCAD offset through and pick that through that point. So I have more or less 2 edges of the roadway. I am now going to go back into Point Cloud, into the Project tab, Polylines, and I am going to again read from CAD and pick these 2 polylines. I'm going to select the 2 of them, one at a time, and elevate to cloud. Here you have similar options. First, site only is the cloud itself. The minimum spacing is every 10 feet, and the point within, again, is the radius. Now, if that is set to small, 0.25 is the default, and there are holes in the cloud, you will end up introducing 0 elevations along the polylines. I'm going to change that to a 2 foot radius instead of the 0.25, and again, the lowest elevation method. If I edit this polyline now, you will see that the polyline is now elevated. You can see a profile below. So some of these were outside the cloud, so I'm going to select those and delete them. And then there were a couple on the other end. Same thing. I'm just going to delete those. And there's my profile of that break line. So OK. Do the same thing for polyline number 3. Elevate to cloud. Same parameters. OK. Edit that. Same situation. Delete the 0 elevation contours. Vertexes, I mean. And here we have one in the middle that it didn't find data within that 2 foot parameter. I will delete that one. I would rather have it interpolate between 2 than to introduce a bad elevation. And at the end, delete. I now can grab these 2 polylines one at a time and draw those back into CAD, and it will remove from the drawing and reinsert the polylines that already exist. So I hit OK and repeat that for polyline number 3. Draw. So these now are elevated polylines. You You can view those quickly through the 3D viewer and see that they are in fact elevated. I am now going to thaw everything again, and I'm going to go into my Surface Manager. There's my existing surface. I'm going to edit that and add entities and add those two polylines in there as break lines. And you can see temporarily that tin lines are drawn. So I'm going to select that one and that one. I hit return, and now I have break lines, and the contours are much improved. Return, done. And then to examine this, I'll go into View, 3D View, and Surface File Viewer. Grab that surface model and look for consistency and bad elevations, and certainly examine those break lines. And there, in the course of about 30 minutes, you have a fairly complete base plan, lots of information to start your project, and those parcel lines can be uploaded directly into the data collector for the beginning survey.